Out in the frozen dark, beyond Jupiter's orbit, where sunlight fades into silence, something impossible is happening. An interstellar object older than our sun itself is leaking water in the coldest region of space. No comet should behave like this. No natural body should be able to melt ice where heat doesn't exist. And yet 3I Atlas does. It glows faint green like a heartbeat in the void. Alive, breathing, shimmering with energy no one can explain. NASA's Swift Observatory recently detected hydroxyl signatures, the chemical fingerprints of water, coming from this frozen traveler millions of kilometers away from the sun. That shouldn't be possible, unless something inside is generating the heat. So what is it? A natural relic of another solar system? A self-heating probe? Or something entirely new? In this video, we'll uncover what scientists have just found, the strange data that defies physics, and the theories that could rewrite everything we thought we knew about interstellar visitors. Stay with us till the end, because the deeper you go into this story, the stranger it gets. For most of human history, the idea that something could enter our solar system from another star was pure science fiction. The space between stars was considered too vast, too empty, too cold. And yet twice before, the universe has proven us wrong. In 2017, astronomers spotted a mysterious object slicing through the inner solar system, a cigar-shaped fragment tumbling silently across the sun's path. They named it Oumuamua, meaning messenger from afar in Hawaiian. It was the first confirmed interstellar visitor, and it behaved like nothing seen before, speeding up as if something invisible was pushing it. 2 years later came 2I Borisov, a second traveler, this time more familiar, a comet with a tail, a mixture of ice and dust, proof that the space between stars might be filled with lost fragments from alien worlds. But nothing could prepare us for the third. In May of 2024, deep sky survey instruments picked up a faint moving dot, small, greenish, and cutting across the starfield in a direction that made no sense. It wasn't bound by the sun's gravity. It wasn't circling anything. It was simply passing through. That's when scientists realized they were witnessing history again. The third interstellar object ever recorded, 3I Atlas. From the very beginning, 3I Atlas didn't behave like a typical comet. Its speed was extraordinary, over 26 kilometers per second relative to the sun, far too fast to have originated from the Kuiper Belt or Oort cloud. Its orbital path was unmistakably hyperbolic, meaning it would visit once then vanish forever. No return, no orbit, just a single cosmic flyby. Its entry angle suggested it came from the direction of the constellation Hercules, the same region associated with several outbound stellar streams. Some astronomers proposed it could have been ejected from another star system billions of years ago, tossed into interstellar space during the birth of a foreign sun. For billions of years, it wandered the void, frozen, alone, untouched. Then, by some extraordinary alignment of chance, it found its way here, into the light of ours. As early telescopes tracked it, something remarkable happened. Unlike Oumuamua, which remained dark and dry, 3I Atlas began to shine. Faint at first, then stronger. Its coma, the glowing envelope of gas and dust, shimmered in unexpected hues of green, an eerie light unlike the bluish or yellow tones of typical comets. To the trained eye, this color alone was a message. Something inside was active. But at that distance, activation was supposed to be impossible. When 3I Atlas was first observed, it was still beyond the frost line, far too cold for water or carbon dioxide to sublimate. Yet instruments from observatories in Chile, South Africa and Hawaii began picking up signs of a coma, a faint trail of dust and gas, suggesting internal heat or trapped volatiles being released far earlier than physics predicted. In the months that followed, the world's biggest observatories turned toward it. The James Webb Space Telescope, orbiting far beyond the Moon, used its infrared sensors to map 3I Atlas's spectral fingerprint. JWST's data revealed something deeply peculiar. The object's coma was dominated by carbon dioxide with an unusually low water signature, unlike any comet in our solar system. Hubble followed soon after, refining size estimates. The nucleus appeared small, maybe 5 kilometers across, yet incredibly dense. Ground-based data confirmed a hyperbolic excess velocity, proving once again that this visitor was not one of ours. Its chemistry didn't match, its orbit didn't fit, and its behavior seemed almost deliberate. A silent body moving too cleanly, too precisely, through the gravitational field of the Sun. But the strangeness didn't stop there. As it passed the orbit of Neptune, 3I Atlas began exhibiting what scientists call pre-perihelion activity, a glowing wake, a green emission caused by excited molecules. The intensity increased over weeks, suggesting the object was warming faster than expected. Some speculated that cracks or fractures on its surface might have exposed internal ices to sunlight, triggering sublimation. Others noted that the data didn't match known models. There was no clear pattern of acceleration, no asymmetric jets pushing it off course. Instead, it seemed to self-stabilize, a behavior rare even among comets closer to the Sun. The mystery deepened when NASA's Swift Observatory detected hydroxyl emissions, the telltale fingerprint of water vapor. While the object was still more than 3.5 astronomical units away, that's roughly the distance of Jupiter's orbit, far too distant for solar heating to cause water to evaporate. And yet, somehow, 3I Atlas was leaking water into space. At first, this data was met with disbelief. Some thought it was instrumental error, background noise mistaken for hydroxyl radiation. Others argued it was outgassing of another volatile like methane or carbon monoxide, mimicking the OH signature. But when independent teams using different observatories confirmed the signal, the reality could no longer be ignored. There was water vapor, there was heat, and there was something happening inside 3I Atlas that no known model could explain. It was as if the object had a pulse, faint, intermittent, but undeniable. By mid-2025, 3I Atlas had become one of the most studied bodies in the sky. Every major observatory, from Hubble to JWST, from the Atacama Large Millimeter Array to small amateur telescopes, was watching. The glow intensified, its tail extended, twisting into strange shapes, sometimes forming what astronomers call an anti-tail, a faint trail pointing toward the Sun instead of away from it, a phenomenon that defied normal radiation pressure mechanics. At times, the tail appeared segmented, as though bursts of energy or material were being released in controlled intervals. Every dataset seemed to raise new questions rather than answer them. Meanwhile, theorists began calculating its energy budget, the amount of sunlight it received versus the energy it appeared to emit. The math didn't add up. Even accounting for reflected light and volatile activity, 3I Atlas was radiating more energy than it absorbed. That discrepancy, a few percent at first, later more, hinted at something deeply unusual: internal heat generation. The source of that heat remains unknown. Some proposed exotic physics like radioactive isotopes trapped within. Others floated more radical idea. Maybe it wasn't a comet at all. Maybe it was something built. But even those who dismissed the wilder theories admitted the data was strange. The ratios of gases were skewed. CO2 vastly exceeded water, CN lines were absent, and the color spectrum didn't match any known solar system analog. The surface reflectivity was low, but the emission lines were strong, suggesting a surface coated in dark, carbon-rich materials with hidden reflective layers beneath. It was an object that seemed both natural and engineered. Too chaotic to be artificial, too organized to be random. Visualize this moment, the JWST infrared sweep, its golden mirrors gleaming against the blackness of space, capturing a distant emerald speck cutting across the void. Parallax stars drift in the background. The object spins slowly, its glow pulsing faintly. From one angle, it looks like a comet. From another, like something half mechanical, its texture patterned, geometric, almost deliberate. And somewhere deep inside, that impossible heat continues to radiate. By late summer, one thing had become clear. 3I Atlas wasn't just another interstellar rock. It was a message written in chemistry, motion, and light. The third visitor in human history had arrived carrying questions that stretched beyond science into philosophy and fear. How many others like it drift unseen between the stars? How many are crossing our skies right now, too faint to notice? And perhaps the most haunting question of all, what if this one isn't drifting by accident? Because the real surprise came months later, when the ice began to melt where no comet should melt, and astronomers realized they weren't just observing an interstellar traveler. They were watching something wake up. By the time 3I Atlas crossed the orbit of Jupiter, its behavior had stopped making sense. The deeper astronomers looked, the stranger it became. Every expectation about how an interstellar comet should act began to break apart. Instead of fading as it moved away from the sun, it started to brighten. Its coma swelled into a green haze that shimmered with faint plasma ripples. Spectrographs showed spikes where no spikes should exist, bursts of emission that came and went like a pulse. The readings were real. The data was clean. The math was wrong. How could something so far from the sun still be evaporating? The numbers said it was releasing water vapor at a rate thousands of kilograms per second, an impossible fountain in the deep freeze of space. NASA's Swift telescope was the first to confirm it. Its ultraviolet sensors picked up hydroxyl radicals, chemical fragments formed when sunlight tears water apart. That meant one thing only: liquid or frozen water was turning to vapor. But 3I Atlas was still 3.5 AU from the sun, where temperatures hover near 180 degrees C. No known comet has ever produced this kind of outgassing so far from heat. When the Swift team double-checked, the signature remained steady, rhythmic, almost deliberate. The same data later came from the Korean KMT net array and the Lowell Observatory. It wasn't a glitch. Something was really venting water. The James Webb Space Telescope turned its infrared eyes toward it next. Webb's detectors peeled apart the light reflected from the emerald coma and found a ratio of CO2 to H2O of nearly 8:1, far outside the range of ordinary comets. There was water, yes, but mixed within a storm of carbon dioxide, carbon monoxide, and unidentified volatiles that didn't belong. The spectral peaks looked like the fingerprints of compounds forged in a colder, older system, molecules formed under the radiation of a dying star. To Webb's scientists, it felt as if the object carried a chemical memory of another galaxy. And then came the glow. Photometric imaging from multiple observatories showed the entire nucleus wrapped in a faint, oscillating light, an electric green shimmer that flickered every few minutes. Brightening, dimming, brightening again. Analysts expected to find dicarbon molecules, the usual cause of a green tail, but they weren't there. The color had to come from something else, perhaps ionized oxygen, perhaps an unknown plasma reaction. Whatever it wasn't following the normal script of comet chemistry. Even its dust tail behaved strangely, at times splitting into twin streams, at others forming a countertail that pointed toward the sun. When astronomers modeled radiation pressure, it didn't match. The only way to reproduce the pattern was to assume small jets firing intermittently from the surface, precise, stable, almost controlled. That's when the whispers began. Could 3I Atlas be harboring a heat source? Could it contain trapped radioisotopes, or worse, an artificial energy core? Officially, scientists dismissed the speculation, calling it premature. Unofficially, data analysts at NASA and ESA began searching for periodic energy spikes. They found them. Every 37 hours, the brightness curve ticked upward by 2%, then fell again. Not enough to prove intent, but enough to unsettle the people watching. No random outgassing should keep time. The comet's surface itself became another riddle. Radar reflections from Goldstone suggested a crust far denser than ice should be. Instead of porous frost, 3I Atlas reflected microwaves as if part of it were metallic, silicate veins laced with something conductive. Some suggested iron-nickel inclusions. Others thought of graphite sheets or even amorphous carbon. But the reflection pattern shifted subtly with rotation, like panels turning under light. It was as if parts of the object absorbed sunlight and released it later, storing energy before letting it go in bursts. If true, that could explain the unexpected heating and raise far bigger questions. Meanwhile, Hubble kept a long-term watch. Over months, it saw the coma expanding and contracting in waves like a heartbeat. During one window in August 2025, its tail brightened, even though 3I Atlas was moving away from the sun. That defied all known comet behavior. The easiest explanation, solar wind impact, didn't fit the direction. The glow had to come from within. On September 10th, a small CME erupted from the sun. 5 days later, Swift detected a surge of ultraviolet radiation from 3I Atlas, a full magnitude brighter than baseline. Coincidence, perhaps? But it made scientists wonder whether the object was reacting to solar activity, as if something inside sensed changes in space weather. Then came the radio silence experiment. Breakthrough. LISTEN coordinated the Allen Telescope Array, FAST in China, and Meerkat in South Africa to scan the hydrogen line frequency 1420 MHz for narrowband transmissions. For 2 weeks in late September, the network listened. Nothing. No pulses, no modulation, just cosmic background hiss. But as the data was being processed, an odd pattern appeared in the polarization angle, a slow, repeating rotation, as though the reflected radio waves were twisting in a magnetic field. Not a message, but not random either. Magnetic turbulence? Possibly. Artificial interference? No one could say. The results were labeled Unclassified Anomaly and stored for further review. By October 2025, 3i Atlas had captured the public imagination. Headlines called it the Green Visitor. Some outlets claimed it was leaking life. Others said it was dying. Scientists were more cautious. The official line, 3i Atlas, is an active interstellar comet exhibiting unusually strong CO2 emission and anomalous water sublimation at large heliocentric distances. But in quiet conference rooms, researchers admitted what the public suspected. The physics didn't line up. Comets don't leak water in deep freeze. Something else was happening. One hypothesis pointed to amorphous ice transition, where frozen molecules rearrange and release heat. But lab simulations showed that even this process couldn't sustain the observed activity for months. Another theory invoked impact microcracks exposing volatile pockets. Yet 3i Atlas's rotation period remained constant. No torque, no acceleration, no jet strong enough to alter its spin. That was the real shocker. Despite venting gas and dust, it refused to budge. Every other active comet jitters under its own thrust, but this one held course as if balanced by invisible hands. Deep in the data, JWST's spectrograph caught a subtler clue, a warm region near the pole, just a few kilometers wide, maintaining a consistent temperature 40 degrees higher than surroundings. It didn't fluctuate with sunlight. It didn't cool at night. Something was generating that heat continuously. Natural decay? Maybe internal reaction? Maybe not. When the team plotted the thermal map, the hotspot aligned almost perfectly with one of the plasma bursts seen earlier. A coincidence that felt like design. The green glow itself seemed to pulse faster. As 3i Atlas neared perihelion, observers described it as breathing, a faint inhale and exhale of light. During one sequence captured by JWST's NIRCam, the nucleus brightened along a curved line, as though something under the crust briefly illuminated the surface from within. Some scientists joked it looked like an engine test. Others stared at the frames in silence. And through it all, the leak continued. Emissions never stopped. Day after day, week after week, water kept streaming from the coldest comet ever observed. By late October, analysts estimated that 3i Atlas had lost more than 2% of its total mass in water vapor alone. If it were purely sublimation, the nucleus should have cracked apart. Instead, it stayed intact. Its rotation smooth, its shape constant. Something was stabilizing it. The anomaly was no longer a data quirk. It was a paradox made visible. A body too cold to melt, too distant to heat, yet somehow alive with vapor. Every image, every spectrum whispered the same impossible truth. 3i Atlas was defying entropy. For the first time, researchers began to speak of it not as a comet, not as debris, but as a system, an object with feedback, behavior, maybe even intent. The words came cautiously in conference papers and closed-door sessions: energy regulation, controlled venting, thermal memory. If those terms proved true, 3i Atlas could be more than an interstellar fragment. It could be a relic of technology, a machine that still functions after billions of years, leaking warmth into the cold. Or it could be something even stranger, a natural mechanism we've never seen before, proof that the universe still hides chemistries beyond comprehension. Either way, it is leaking water in the cold, and no one can explain how. By October 2025, 3i Atlas had split the scientific community in two. Every new observation widened the fracture line between those who believed it was a perfectly natural, if exotic, interstellar comet, and those who suspected something far stranger. The data didn't care who was right. It kept streaming in, silent and unyielding, spectral lines of water and carbon dioxide, thermal pulses from within, a glow that refused to fade. And in every lab and observatory, one question echoed like static through the noise: what's keeping it warm? The cautious side, the naturalists, began assembling explanations. The first argument was cosmic ray heating. Space is never truly empty. High-energy particles accelerated by ancient supernovae constantly strike every drifting object. Over millions of years, those collisions can burrow deep into a body's crust, cracking molecules, storing latent heat. If 3I Atlas spent eons bathing in that invisible radiation, maybe its interior had built up a reservoir of trapped energy. As it entered the relative warmth of our solar system, that reservoir might finally be bleeding out. A slow exhale after a billion-year silence. The math almost worked. Almost. The flux required would have to be 10 times higher than what cosmic ray density allows. Yet for those desperate to stay grounded in physics, almost was close enough. Others pointed to microfractures. In this model, 3I Atlas is no miracle, just geology on an interstellar scale. The surface, hammered for eons by radiation, could be riddled with stress lines. A tiny impact or sudden thermal change might open a vein of buried ice. Sunlight, weak though it is at 3 astronomical units, would strike that cavity, triggering a miniature geyser. Multiply that by thousands of fractures, and you'd get a faint, persistent leak. Elegant, safe, comforting. But the problem was pattern. Natural cracks vent chaotically, not rhythmically. The pulse of 3I Atlas was steady, patient, timed. A third camp invoked cryovolcanism, ancient and cold. Maybe the object isn't merely sublimating, maybe it's erupting in slow motion. On certain icy moons like Enceladus or Triton, carbon dioxide and nitrogen can trap enough pressure to burst through frozen crusts, releasing fountains of gas. If 3I Atlas formed near such a volatile, rich region, perhaps deep pockets of CO2 ice are still trapped inside. As heat seeps inward, these pockets expand, venting periodically through crustal vents. Some papers even described it as a CO2 volcano effect, a ghost of geologic activity from another solar system. But again, the energy mismatch loomed. At the temperatures measured, even CO2 should remain locked solid. Something had to start the reaction. Then came the delayed outgassing theory, a kind of celestial time lag. The idea, sunlight that penetrated the surface months ago could still be diffusing inward, reaching deeper volatile layers only now. The heat travels slowly through porous dust, and when it finally meets the right material, vapor escapes. This could create bursts appearing too late for their distance. The floor 3I Atlas has shown no rotation-dependent variation. If sunlight were the trigger, brightness would fluctuate with spin. It doesn't. Its behavior is unnervingly even, as if the whole body obeys a single internal thermostat. Across the divide, the speculative side began whispering louder. They looked at the same data and saw not randomness but design. What if the heat isn't trapped at all? What if it's generated? Some proposed radioactive decay as a hidden engine. Perhaps the core contains isotopes, aluminum-26, thorium, uranium, relics of its parent star's explosion. Those isotopes could still be decaying, releasing warmth from within. It's plausible, meteorites on Earth carry such traces. But even the richest deposits would fade after a few million years, and 3I Atlas has been wandering for billions. To still radiate now, it would need something self-sustaining, something replenished. And that's where imaginations began to stir. A more radical notion followed, electromagnetic induction. As 3I Atlas crosses the sun's magnetic field, moving through streams of charged particles, currents could be induced inside a conductive structure. Think of it as a cosmic dynamo, a rock that charges itself as it flies. The solar wind would become its fuel, the magnetic drag its spark. The idea isn't new. Induction heating explains plasma tails in some comets. But not at this scale, not with such precision. For the induction model to fit, 3I Atlas would need metallic veins or a hollow conductive shell. When radar echoes showed hints of dense inclusions, believers felt vindicated. The skeptics saw coincidence. And then, inevitably, came the Avi-Loeb hypothesis. Half theoretical exercise, half philosophical dare. Loeb suggested that interstellar objects like Oumuamua and 3I Atlas might not be random debris at all, but fragments of engineered technology, derelict probes, ancient sails, automated beacons adrift between stars. If it's leaking where it shouldn't, he mused in one interview, maybe it's not leaking, maybe it's venting. The distinction, he said, mattered. A malfunctioning rock bleeds energy until it dies. A machine vents to survive. Perhaps the green glow, the steady water loss, the heat pulses, all of it could be a maintenance process, not decay. The object could be stabilizing itself, keeping internal pressure balanced as it absorbs solar radiation. In other words, self-regulation, not outgassing. Loeb's followers went further. Some modeled the possibility of a CO2-based cooling system, an engineered mechanism using volatile gases as heat sinks, just as spacecraft use ammonia or freon. If 3I Atlas were a long dormant probe awakening under sunlight, it might purge CO2 to manage internal temperature, explaining the wild gas ratio Webb observed. Others proposed optical signaling. The rhythmic brightening could be low-bandwidth communication, not reflection. Every cycle is a tick, wrote one paper, perhaps the heartbeat of an ancient system recharging after aeons. To most astrophysicists, it read like poetic fiction. To a few, it felt too close to pattern to ignore. The contrast in language became symbolic. The naturalists spoke of sublimation fronts, dust jets, outgassing physics. The radicals preferred self-regulation, venting control, energy conservation. Both sides stared at identical graphs, but one saw chaos, the other choreography. Even terminology like pulse versus flare divided them. In one data set, a skeptic noted random thermal fluctuations. A believer annotated the same line with operational cycle detected. Science, after all, is interpretation written in equations. In late 2025, a heated panel at the International Astronomical Union's symposium showcased the rift. One researcher presented a detailed thermal model. If cosmic rays, induction, and subsurface CO2 pockets all combined, they could just barely reach the required temperature to release water. Physics holds, he concluded. Avi Loeb, speaking remotely, smiled thinly. If physics holds, he replied, then so does curiosity. A natural rock cannot choose to balance its own output. The silence that followed was longer than applause. Outside academic circles, the debate turned mythic. Online communities called 3I Atlas the Green Machine, the Whispering Comet, even the Watcher. Videos went viral claiming it was transmitting toward Mars. Others said it was alive. But beneath the noise, the genuine tension remained, science confronting its own limits. Because for every natural explanation, the math strained a little further, and for every unnatural one, evidence stayed just out of reach. And somewhere between both camps lies the truth. Maybe unromantic, maybe extraordinary. Cosmic ray heating could coexist with artificial structure. Induction could drive both a magnetized rock and a forgotten probe. Nature and design might not be opposites at all, but points on the same spectrum. Perhaps 3I Atlas is neither miracle nor machine, but something in between. An artifact born of physics so complex it feels intentional. What everyone agrees on is this: it shouldn't be doing what it's doing. It shouldn't glow in the dark. It shouldn't breathe water in the cold. It shouldn't pulse like a living thing. And yet it does, methodically, insistently, beautifully. If it's natural, it's rewriting comet science. If it's not, it's rewriting human history. The deeper scientists probed into 3I Atlas's chemistry, the stranger it became. Numbers that should have described a simple, icy traveler began to look like the ingredients of another universe. Every comet, no matter where it comes from, obeys a few familiar patterns. Water dominates, carbon dioxide lingers, cyanogen glows faintly, and dust dances along predictable spectra. But when the James Webb Space Telescope turned its infrared spectrometer toward this interstellar object, the ratios that emerged broke all expectations. The instrument's readings were clear: CO2 to H2O, roughly 8:1. In the entire history of comet observation, nothing like it had ever been recorded. Not in our solar system, not in any survey, not even in simulated exoplanet chemistry. It was as if 3I Atlas had been built from a different recipe of matter itself. To understand how wrong that number is, you have to understand the norm, ordinary comet. Those born from the same dust and gas as our planets carry water as their heartbeat. In most, H2O makes up half or more of their volatile output, followed by smaller traces of carbon dioxide, carbon monoxide, ammonia, and organic compounds. But in 3I Atlas, the entire ratio flipped. Water became the minority. Carbon dioxide reigned supreme. It was as though the comet had never formed near liquid oceans or warm dust. It had been forged in a colder, sharper kind of space, a place where carbon chemistry ruled and water was almost a contaminant. If this was natural, it spoke of a birthplace near the frozen edge of another star's disk, a world so distant that even its ices were alien. And if it wasn't natural, then maybe that ratio wasn't composition at all, but function, the exhaust of something operating in disguise. The oddities didn't end there. When astronomers scanned the ultraviolet band, searching for the telltale cyanogen emission line, the CN signal, a universal marker of active comets, they found nothing. CN lines should glow bright blue around 388 nanometers, yet 3I Atlas remained silent. In a normal comet, ultraviolet photons strike the nucleus, splitting nitrogen-bearing molecules and producing CN radicals that fluoresce against the vacuum. Their absence meant one of two things. Either the comet lacked nitrogen chemistry entirely, or something was absorbing that light before it escaped. Both possibilities were unnerving. A comet without CN was like a heartbeat without a pulse, chemically alive but eerily quiet. Then came the question of surface activity. By modeling its light curve and thermal response, researchers estimated that over 20% of 3I Atlas's surface was active, nearly 4 to 5 times higher than typical solar system comets, which usually vent from just a few fractured spots. That number alone implied that the object wasn't just leaking, it was working. The entire surface seemed to breathe in rhythm, each section contributing to the green mist that haloed it. For a body barely a few kilometers wide, that level of uniformity bordered on the impossible. If it were natural, the structure of its crust would have to be astonishingly even, its fractures perfectly distributed. A comet engineered by mathematics itself. If it weren't natural, the alternative was more chilling. A surface designed to radiate evenly, dissipating heat like a cooling grid. The green light, that eerie emerald aura, became the next obsession. Early on, scientists assumed it came from dicarbon molecules, C2, which emit brilliant green fluorescence when sunlight excites them. Dicarbon is the reason most comets glow green as they approach the sun. But when spectroscopy isolated the relevant wavelength, the signature was missing. There was no C2, no dicarbon chemistry at all. The green light had to come from something else, perhaps oxygen plasma, perhaps excited atomic transitions, or something even less familiar. One theory suggested plasma excitation caused by charged particles swirling around the object's magnetic field, if it had one. That would explain why the glow intensified irregularly, almost like auroras wrapping around a tiny magnetized core. Another interpretation was stranger still, a photoelectric effect caused by metallic dust reacting to ultraviolet light. An emission more like the shimmer of an alloy than the vapor of ice. Whatever the cause, it wasn't standard comet chemistry. It was something new, or something ancient, finally seen again. When Hubble and Neuer Lab combined their optical data, another anomaly surfaced, an expanding anti-tail, a feature so rare it's been observed only a handful of times in history. In simple terms, an anti-tail is a thin stream of dust or ions that appears to point toward the sun rather than away from it. It's usually caused by perspective, Earth crossing the plane of the comet's orbit, but the structure seen in 3I Atlas defied geometry. It didn't just appear to point sunward, it physically curved toward the light. Time-lapse images revealed the anti-tail growing denser and brighter over time, scattering sunlight as if particles within it were reflective. Some even speculated it might be an ion beam, a jet of charged gas following a magnetic trajectory rather than solar pressure. To see it unfold in near real time was mesmerizing, a green flame stretching backward through the void, as though the comet were being pulled toward its origin rather than pushed away from it. Every molecule, every photon, every reflection from 3I Atlas seemed to misbehave. Ratios that should have balanced refused to do so. Spectral peaks appeared where gaps should have been. Infrared readings showed small flickers, thermal microbursts that hinted at active chemistry happening just beneath the crust. Theories bloomed like frost flowers. Perhaps internal CO2 pockets ignited under pressure, or solar particles triggered chain reactions in exotic ices. But when laboratory simulations tried to recreate the ratios, they failed. The models melted too quickly, collapsed under their own heat, or produced different emission lines altogether. Whatever 3I Atlas was made of, its chemistry didn't play by the same rules as ours. Some researchers began to frame it differently. It's not that the ratios are wrong, one NASA scientist said. It's that they belong to a chemistry we haven't met yet. A sobering thought. that matter born under another star might not conform to the periodic expectations of our own. But for others, that explanation was too kind. They pointed out the precision of the ratios. 8-to-1 wasn't a coincidence, it was arithmetic. Nature rarely works in perfect fractions. Machines do. When JWST plotted the emission curve over time, the CO2 output oscillated in perfect waves, like a repeating signal. If 3I Atlas were merely venting gas, the release would fluctuate chaotically. Instead, the rhythm looked controlled, as if pressure was being released on a schedule. The deeper the analysis went, the more it felt like decoding an equation hidden inside the object. Chemical balances lined up in ratios too neat to be random. Even the distribution of elements on its surface seemed ordered. A higher concentration of carbon near the equator, water near the poles. Hubble's color maps displayed smooth gradients instead of patchy outbursts, as though the surface were deliberately zoned. Some theorists compared it to a reactor in equilibrium, a body maintaining chemical balance across its crust. For believers in the artifact hypothesis, this was the smoking gun. For skeptics, it was coincidence amplified by imagination. But even the skeptics were running out of metaphors. One of the strangest findings came from polarization analysis. Light reflected from 3I Atlas exhibited a shifting polarization angle, cycling every few hours. This meant the surface wasn't scattering light like a simple dust cloud. It was interacting with it, refracting it through changing microstructures. A natural explanation might involve rotating crystalline frost layers, but the rate of shift matched the thermal pulse measured days earlier. If those two signals were linked, the implication was astonishing. Chemistry responding to energy, energy responding to light, all synchronized in feedback. That's not just random physics, that's a system. By late 2025, it became clear that 3I Atlas wasn't just chemically unusual. It was chemically consistent in its weirdness. Every new instrument confirmed the same pattern. Too much carbon dioxide, too little water, missing cyanogen, absent dicarbon, and an expanding anti-tail glowing against the sun. The ratios didn't change. They held steady as though locked by design. Most comets evolve as they approach the sun. They crack, vent, fragment, and alter their chemistry as heat penetrates deeper. But 3I Atlas stayed stable. It didn't break apart. It didn't lose brightness. It kept breathing, controlled, efficient, precise. Every molecule seems out of balance, one astronomer said quietly after reviewing the spectra, as if built from a different chemistry altogether. The quote spread across scientific circles, half awe, half disbelief. Because if that was true, if the elements themselves carried alien ratios, then 3I Atlas wasn't just an interstellar visitor. It was a messenger from a part of the universe where the rules themselves have changed. And for the first time in modern astronomy, the chemical language of a comet had begun to sound almost mechanical. There is one rule that every astronomer lives by: cold things stay cold. In the deep vacuum beyond Jupiter, where sunlight fades to a whisper and space sits just 3 degrees above absolute zero, there should be nothing left to burn. And yet, 3I Atlas glows. It leaks water where no comet should. It radiates heat no orbit can justify. Something inside it is alive with energy, invisible and patient, pulsing beneath the crust like a buried heart. The question no one can shake is simple. What could possibly be powering it? The first and most cautious theory is the one that fits inside the known universe. A nuclear ghost born from natural physics. When stars die, they scatter fragments of their insides into the void, radioactive isotopes, heavy elements forged in supernova shockwaves. Some of those atoms, aluminum-26, uranium-238, thorium-232, carry decay chains that can last billions of years. If 3I Atlas was born near such an explosion, it might have swallowed those isotopes like embers trapped in snow. For eons they would lie dormant, sealed inside rock and ice, releasing tiny drips of warmth as they decayed. A natural nuclear battery adrift between stars. It's poetic and plausible. Meteorites on Earth still carry trace heat from the same process. But there's a catch. The power output of decay fades predictably with time. To still be glowing now after perhaps 4 or 5 billion years in exile, 3I Atlas would need isotope concentrations 100 times higher than any natural rock can hold. Either it was forged in a supernova's direct blast, or it's something built to last that long on purpose. Hypothesis 2 looks outward instead of inward. Maybe 3I Atlas doesn't contain the power. Maybe it borrows it. As it cuts through the solar wind, it travels through an ocean of charged particles flowing from the sun. If its body is even partially metallic, those particles could induce electrical currents inside it, turning the comet into a kind of cosmic dynamo. This is electromagnetic induction, the same principle that spins the turbines on Earth. Magnetic lines of force slicing through conductive material to create heat. It's real physics, and it works even in vacuum. The faster 3I Atlas moves through solar plasma, the stronger the potential current becomes. Every encounter with a coronal mass ejection could pump more energy into its core, charging it like a slow-turning generator. The idea fits some of the data: periodic thermal spikes, plasma discharges, a glow that flares days after solar events. The anti-tail seen by Hubble could even be a stream of ions guided by those induced fields. But again, the mystery deepens. To sustain this effect, the interior would need organized conductive layers, perhaps alloys or graphite sheets, aligned just right to channel the flow. Nature can build such layers, but rarely with that symmetry. It's as though the object was wired. Then there's the third hypothesis, and that's the one most scientists refuse to print, at least not in formal journals, the one whispered in long, midnight conversations after the data feeds go quiet. What if 3I Atlas isn't merely conducting energy, but producing it? What if inside that frozen crust, beneath kilometers of carbon ice, lies a heat source designed to survive forever? Imagine an internal reactor, maybe fission-based, maybe something we don't yet understand, using carbon dioxide and trace hydrogen as both coolant and exhaust. The periodic jets we see as outgassing could be controlled venting, releasing built-up heat while maintaining equilibrium. It would explain the precision of its ratios, the rhythmic pulses, the way its brightness curves like a heartbeat instead of a random flare. To human eyes, it looks like chemistry. To a machine, it might look like maintenance. There's precedent, at least conceptually. NASA's Voyager probes, launched in the 1970s, still hum in the dark thanks to their RTGs, radioisotope thermoelectric generators that turn the decay of plutonium into electricity. They are, in essence, tiny nuclear hearts encased in metal, radiating warmth into endless night. Decades later, they're still warm enough to touch. If an ancient civilization wanted to send probes across interstellar distances, why not build something similar? But magnified, armored, cryogenically sealed. 3I Atlas could be the Voyager of another sun, a machine designed to drift silently for ages, waking only when it senses a new star. Maybe that's what's happening now. The warmth we detect could be the afterglow of reactivation, a reactor stirring after eons asleep. Of course, there are natural ways to mimic even this. In laboratory ice, we've seen phase transitions release heat. When amorphous water rearranges its molecules into crystalline structures, it emits a faint warmth. If the nucleus of 3I Atlas is riddled with pockets of amorphous ice, those transitions could occur gradually, creating localized hotspots that radiate outward. Yet in 3I Atlas, the warmth seems organized, migrating in waves across its surface instead of spreading randomly. Instruments record rolling patterns. Heat rising near the poles, drifting toward the equator, then fading, like a pulse traveling through veins. No natural comet does that. Even as it vents gas, its rotation remains stable, perfectly balanced. No spin acceleration, no wobble. Something inside is compensating. When JWST captured its thermal profile in infrared, the image looked like a living organism under a heat camera. Glowing fractures, pulsing veins, streaks of light that throbbed and cooled as though circulating warmth through the crust. In some frames, the glow ran in loops, beginning and ending at the same coordinates. That's not geological chaos, that's circuitry. Each pulse released a small burst of vapor, the green shimmer brightening seconds later. The feedback was unmistakable: heat leading light, light leading chemistry, chemistry leading back to heat. A closed loop? Those who leaned toward the artifact theory began whispering about cryogenic systems, the kind used in advanced spacecraft to preserve instruments. On Earth, engineers use closed-cycle heat pumps to move energy away from critical components. What if 3I Atlas does the same, venting CO2 to cool an internal core, then reabsorbing frozen material later? A kind of self-repair mechanism, ancient but functional. The ratios of gases could be its blueprint. 8 parts CO2, 1 part H2O, coolant versus lubricant. Its anti-tail could even be an exhaust plume. If this sounds absurd, remember that a century ago the idea of comets being dirty snowballs sounded absurd too. Science evolves at the edge of disbelief. But even skeptics admit one unnerving truth: the object's energy budget doesn't balance. It emits more infrared radiation than it absorbs from sunlight. There's no escaping that math. Whether through nuclear decay, magnetic induction, or something else entirely, 3I Atlas is generating internal heat. The simplest explanation is often the right one, but sometimes the simplest explanation is the one we're least ready to accept. During a private symposium in Geneva, one astronomer summarized it bluntly. "If we ever retrieve a fragment and it's still warm," he said, "the mystery ends there." The room went silent, because in that single sentence lay the border between wonder and revelation. A warm rock is chemistry. A war machine is history. For now, all we can do is watch. Instruments continue to record its glow. Data continues to defy the equations. Each new observation adds to the paradox: a comet that heats itself, a traveler that leaks life in the cold. Maybe it's nothing more than physics we don't yet grasp. Or maybe it's proof that somewhere, long before us, someone else learned to build engines that could outlive stars. Out there, between worlds, 3I Atlas drifts. A frozen vessel, cracked and radiant, carrying the faint hum of power across the dark. Whatever drives it, whatever breathes through its ice, still runs. And that perhaps is the most astonishing discovery of all. Because, in the silence of the solar wind, this thing from another sun is not dead matter at all. It is alive with heat. The engine in the ice still burns. Every mystery in the sky comes with a clock, and for 3I Atlas, the countdown has already begun. Astronomers around the world have marked the coming months as a once-in-a-lifetime opportunity, a brief alignment of spacecraft and telescopes that could finally reveal what this visitor truly is. They call it the watch window, a cosmic choreography of machines and eyes turned toward one faint, impossible glow. In that silence beyond Jupiter, 3I Atlas keeps leaking water, breathing its strange vapor into a vacuum where no water should exist. Now, for the first time, a fleet of orbiters and probes will try to catch it in the act. Because if there's ever been a moment when the truth might break through the static, it's now, between the last weeks of September 2025 and the dawn of the new year. And what they see might change everything. The first to prepare is ESA's Trace Gas Orbiter, a spacecraft orbiting Mars, originally designed to study methane and other volatiles in the Martian atmosphere. In mid-October 2025, the orbiter's instruments will align with 3I Atlas's trajectory as the object drifts just beyond the orbit of the red planet. For a few critical hours, its spectrometers will scan the green haze from a unique angle, filtering sunlight through the faint gases of the comet's coma. If there's structure in that glow, if it flickers in pattern or frequency, the orbiter will see it. Some scientists are already calling this alignment the Martian eclipse window, a chance to use Mars's shadow as a natural filter to isolate emissions. The hope to distinguish between random sublimation and controlled venting. If the water leak is chemical, the data will scatter like noise. But if it's regulated, if it carries rhythm, the readings will hum in order. One scientist described it simply: when the Martian instruments listen, we'll know if it's breathing or speaking. Next comes the Parker Solar Probe, humanity's fastest spacecraft, skimming the Sun's outer atmosphere on its final perihelion in November 2025. Normally Parker studies the solar wind, but during this orbit, its whisper imager and particle detectors will cross within a magnetic corridor that intersects 3I Atlas's projected plasma tail. No one expected this coincidence. It's as though fate aligned two ancient travelers, one built by us, one older than the sun. If Parker's instruments detect charged particle variations, plasma waves, or unexpected magnetic ripples, it could confirm that 3I Atlas is actively interacting with the solar wind, maybe even generating electromagnetic fields of its own. Engineers have already recalibrated sensors to flag anomalies between November 2nd and 8th, when Parker passes closest to the region of space where the comet's tail is predicted to drift. A small spike in plasma density could prove induction heating. A pattern of pulses could suggest something else entirely. The possibility hangs in the air like a promise or a warning. But before either of those missions capture their data, another event will unfold, one that could change the entire story overnight. Around September 25th to 30th, 2025, the Sun is forecast to release a coronal mass ejection, a burst of solar plasma that will surge outward through the solar system. Modeling from ESA's Solar and Heliospheric Observatory shows its trajectory intersecting the orbital path of 3I Atlas. If that CME connects, it could trigger the most revealing phenomenon yet. A flare, an electrical reaction, a mini eruption as charged solar particles slam into the comet's electromagnetic field. If induction theory is right, the impact will cause a measurable heat spike, maybe even a visible burst of light. If the artifact theory is right, it could do something stranger. Wake it up. Astronomers have nicknamed the event the collision of fire and ice. For a few brief hours, instruments from Earth, Mars, and near the Sun will all be watching simultaneously. The JWST, though limited by pointing constraints, will track the thermal profile remotely in infrared. The Hubble Space Telescope will photograph any brightening invisible light. The solar orbiter stationed between Earth and Venus will monitor magnetic flux. And deep below Earth's surface, the Allen Telescope Array will listen on hydrogen line frequencies, just in case the flare coincides with a radio pulse. The coordination is unprecedented, an armada of watchers spanning the solar system, synchronized on one target. It's not just observation, it's interrogation. Then comes December, the most anticipated phase of all. After months hidden behind the Sun's glare, 3I Atlas will reappear, emerging from solar conjunction around December 18th, 2025. For weeks, it will have been invisible, its faint green shimmer lost in the light. When it returns, astronomers expect surprises. Historically, many comets undergo drastic changes after perihelion. Jets reorient, surfaces fracture, tails reverse. But 3I Atlas has defied every historical pattern so far. Its rotation hasn't shifted, its structure hasn't weakened. Instead, simulations predict it will brighten again, potentially more than before. Theories split here. Some predict a total fading, others a second activation event, a phenomenon few have dared to name aloud. The term circulating in closed research circles is reboot. In that reappearance window, every telescope that can move will be pointed upward. The James Webb Space Telescope will conduct a deep-field infrared sweep from December 20th onward, searching for residual heat pockets or localized flares. The European Southern Observatory's VLT will track polarization shifts to measure the direction of light scattering, a test that could reveal whether the antitail is still active or has changed polarity. Even ground-based amateurs are joining in, forming a global collaboration known as the Atlas Watch Network, pooling images to track subtle variations. It's the largest coordinated skywatch since Oumuamua in 2017, but this time with more questions and fewer answers. If 3I Atlas behaves like a comet, the outgassing will fade as it moves farther from the Sun, the coma will shrink, the glow will die, and its strange chemistry will freeze again. But if it's something more, if the heat comes from within, then it will not fade. The emission lines will hold, the leak will continue. Maybe the water vapor will shift from random jets to measured vents, the way engines idle after a test. Some even speculate it could change direction, adjusting its trajectory minutely. That would be the final test. An undeniable signal that we are not watching geology but guidance. For now, it's only speculation, whispered in digital hallways between data teams, written in careful language, active vector variation under post-perihelion monitoring. Translation: if it turns, we're not alone. The Trace Gas Orbiter will send its data first, expected by early November. Spectral graphs of hydroxyl emissions, ultraviolet fluorescence, gas distribution. Then Parker's instruments will downlink magnetic readings, comparing them to baseline solar wind models. ESA will cross-correlate both, looking for overlap. If the timing matches, as if a plasma pulse in Parker's data coincides with a flare in the comet's brightness, the induction model will jump from theory to evidence. At that point, even the skeptics will have to admit that something inside 3I Atlas is responding to the solar wind like a living circuit. By mid-December, Hubble will capture high-resolution imagery as it emerges from behind the Sun, revealing whether the antitail has changed or reformed. A persistent antitail would mean ongoing outflow directed by magnetic lines, not solar radiation. In other words, something sustaining it. That same month, SphereX, NASA's upcoming all-sky spectral mission, will begin preliminary calibration scans that might include 3I Atlas in its field. SphereX's sensitivity could detect faint chemical evolution, shifts in carbon or oxygen isotopic ratios, revealing whether new gases have been produced since the last observation. If the ratios change, it's natural chemistry. If they don't, it's controlled. Meanwhile, rumor has it that Breakthrough Listen, the private SETI initiative, plans to resume passive monitoring on the hydrogen line frequency during December, just in case. Not for a message, but for anomalies. A narrowband carrier wave would be enough. Even a steady hum that correlates with its rotation could redefine the discussion. Some scientists privately joke that 3I Atlas has become the universe's most famous maybe. Every time it surprises us, it tightens the loop of curiosity around our planet. The truth is, these next few months will decide its story. If the green glow fades into silence, we'll call it physics. If it brightens after December, we'll call it history. Either way, it will teach us something about energy, matter, and endurance in the vacuum of space. Already, instruments detect that faint warmth that won't fade, a constant few degrees above background, whispering from across hundreds of millions of kilometers, like a candle refusing to go out. In one internal NASA memo leaked to science forums, a researcher wrote a single line that spread like wildfire across social media. When it returns, we'll know whether the leak was chemical or controlled. It's become the unofficial tagline of the 3I Atlas campaign, equal parts science and suspense. Because after all the theories and data, the only real test is time. Time and patience and silence. And so the watchers wait. From Mars to Mercury, from the sun's edge to the deserts of Chile, a network of machines and humans holds its breath, staring at a faint green point that should have been just another comet. Instead, it became a mirror, one that reflects not just sunlight, but our need to understand what we're really seeing. If in December it reappears and flares again, the debate ends. If it stays warm, the mystery deepens. But either way, when it comes back from behind the sun, the world will be watching. And for the first time in history, the universe might finally whisper back. Because in those final weeks of 2025, under the quiet glow of an emerald tail, humanity will find out whether 3I Atlas was just a comet, or something that once had a purpose. And when it returns, we'll know whether the leak was chemical or controlled. There are moments in science when data stops being numbers and starts being poetry. When the lines on a graph feel like sentences written by something older than language. 3I Atlas has become one of those moments. A frozen traveler from another star that refuses to follow the rules of silence. For nearly a year, we've watched it bleed vapor into a vacuum that should have kept it still. We've seen its chemistry twist into ratios that defy every model, its light pulse like a living organism, its orbit glide with the calm precision of intent. And now, as it nears its last appearance before vanishing forever, the truth we find will depend not on what we want to believe, but on how far we're willing to listen. If it's natural, then we've stumbled upon a window into alien planetary systems, a glimpse of how other stars build their worlds. Its chemistry, rich in carbon dioxide, low in water, stripped of cyanogen, tells us that not every planet is born from the same fire. Somewhere, light years away, there may be suns whose comets breathe carbon instead of water, where oceans never form and atmospheres glow green in ultraviolet light. 3I Atlas might be a messenger from that reality, a shard of another system's history drifting across the interstellar void to remind us that our solar system is not the template, only one design among billions. It's humbling to think that a block of ice can outlive its parent star, carrying its secrets across galaxies like a time capsule frozen before humanity ever existed. If that's all it is, natural, accidental, miraculous in its endurance, then it's still one of the most profound discoveries of our time. Proof that the chemistry of creation is infinite. But if it's not natural, if that internal heat, those perfect ratios, those rhythmic flares aren't coincidence, then 3I Atlas isn't a comet at all. It's a survivor. A relic of technology so old it's become indistinguishable from nature. A machine that has survived the deep. Think about what that means. Something built by intelligence, maybe biological, maybe artificial, sent into the dark billions of years ago, still functioning, still maintaining itself, still leaking warmth in defiance of entropy. We would be witnessing the longest-running machine in the universe, a device so patient it outlived civilizations, perhaps even the species that created it. And we wouldn't have found it through communication or intent, but through physics, through a leak that shouldn't exist. Not a beacon that shouts, but an engine that whispers. That whisper is what keeps scientists awake at night. Because every time 3I Atlas pulses, every time it breathes vapor into space, it challenges the most fundamental assumption we've made about life and intelligence, that it must look like us.
Maybe it doesn't speak in radio or mathematics or words, but in vapor, in light, in silence.
Maybe the universe has been talking this entire time, and we just never knew how to listen. When the WOW signal arrived in 1977, we called it a message because it fit the language we expected. Binary, narrowband, organized. But what if messages don't come as signals at all? What if they come as phenomena? An anomaly that refuses to die, a pattern that repeats in chemistry, a leak that happens too perfectly to be random. Maybe 3I Atlas isn't sending a message to us. Maybe it's simply being the message, endurance itself as communication, persistence as language, the act of surviving the deep as the ultimate statement of purpose. If that's true, then this isn't just astronomy, it's archaeology on a cosmic scale. We're digging into the wreckage of the universe's oldest stories, finding artifacts that still hum with warmth. And that warmth forces us to ask uncomfortable questions. If something like 3I Atlas was built, how many others are out there? Are they probes, scouts, or fossils? Were they meant to explore or to wait? And if one of them ever noticed the flicker of our satellites, or the faint glow of Earth's night side, would it recognize us as descendants or as strangers? The deeper we stare into this green ghost, the more it stares back, reflecting our curiosity, our arrogance, our loneliness. There's a moment late at night when observatories go quiet. The instruments keep recording, the graphs keep scrolling, but the chatter stops. In that stillness, some researchers say they can almost feel 3I Atlas out there, not as a comet, but as presence. A slow, drifting pulse moving through the dark, older than everything we've built, still burning with internal fire. Some call it a relic, others a coincidence. But to many, it's starting to feel like a mirror. One held up by the universe to show us how fragile, how fleeting, and how powerful existence itself can be. Whether it's a comet or a construct, 3I Atlas has already changed the story. It's forced humanity to remember that the cosmos isn't silent. It's simply waiting for the right question. The vapor it leaks is a signature. The light it glows is a syllable. The rhythm it holds is a sentence. We don't yet know the language, but we're learning the grammar, the physics, the patience, the persistence of something that shouldn't be alive, yet somehow is. And so as it drifts back toward the edge of sunlight, we're left with two possibilities, both equally staggering. If it's natural, it's a new chapter in the physics of creation. If it's engineered, it's proof that intelligence can outlast extinction. Either way, the result is the same. We are not just observers anymore. We're participants in a story that began long before us and will continue long after we're gone. A story written not in ink, but in ice and light. Maybe, in the end, it isn't leaking water at all. Maybe it's speaking, softly, in vapor, in light, in silence. A language of endurance, a dialect of time. Every molecule it releases might be a memory dissolving into the void, a data trail evaporating across eternity. And maybe, just maybe, it's not trying to communicate with us. It's trying to remind the universe itself that it's still here. So as we wait for it to pass behind the sun, as the telescopes fall silent and the sensors dim, we listen.
Because when it returns, it may not be the same.
It may shine brighter, or it may disappear forever. But whatever happens, one truth will remain. Something out there whispered back, and for the first time humanity heard it. In the next episode, we'll follow 3I Atlas as it crosses behind the sun, where no signal can reach and no telescope can see, to uncover whether the whisper grows louder or fades into the cosmic quiet once more. Because in this story, silence isn't the absence of sound, it's the space between discoveries. And sometimes, in that space, the universe answers.